previously we discussed about a binomial distribution. Today we discuss about a Poisson distribution. Poisson distribution is a word. Poisson distribution is a limiting case of a binomial distribution. What is the meaning of this one? Meaning of this one is if a number of a trial is too much large, means if n tends to infinite and p tends to 0, means the probability of a success is too much small, then this one is a what? This one is a Poisson distribution. So there are different method to derive the Poisson distribution with the help of a binomial distribution. Means with the help of a Stirling approximation, we able to find out with the help of a binomial distribution Poisson distribution. Directly also we able to derive the Poisson the probability mass function of a Poisson distribution. But here we are going to derive with the help of directly by simplification of a probability mass function of a binomial distribution using the concept, means if n tends to infinite and p tends to 0, then np tends to one another new constant lambda, then we try to derive the probability mass function of a Poisson distribution. Now, what is the Poisson distribution? Poisson distribution So this one is also what under the category of a discrete probability distribution. Discrete probability distribution. Discrete probability distribution. Probability distribution. Distribution. So this one is a limiting form of a binomial distribution. Limiting form of binomial distribution. Binomial distribution. Binomial distribution. Binomial distribution. So as we say that n tends to what? N tends to infinite. Number of a trial tends to infinite. N is a what? N is a number of a trial. So number of a trial tends to infinite. And probability of a success be denoted by the p. P is the probability of a success, p tends to 0. Probability of a success tends to 0. Then we find a what? We find a probability mass function of a Poisson distribution. And here we introduce a new constant lambda, and the value for this one equal n into p. And what is the binomial, or what is the probability mass function of a binomial distribution? This one is a v npx. If we write basically there is a two parameter, but if we write what? Npx, x is also these are treated as a variable, then this one is a what? This one is a ncx p to power x q to power n minus x. For x equals 0, 1, 2 up to what? Up to n. So this one is a probability mass function of a binomial distribution. Otherwise, for other values of a random variable, probability is a 0. So here we write what? P equal, what is the value of p? Lambda equal n p. Lambda equal np. Then what is the value of p? P tends to p equal what? Lambda by n. And n tends to infinite. So here we use this one. So what is the value for this one? Means Poisson distribution here, v x and p NP, this one equal factorial n, means the factorial n divided by factorial x, factorial n minus x, factorial n minus x, factorial n NCX, factorial n, factorial x, factorial n minus x. And p to power x means p equal lambda by n, so this one is a lambda by n to power x, and q can be written as 1 minus p, 1 minus lambda by n to power n minus x. So this one is a what? This one is a in term of a lambda. So in term of a lambda, now we simplify this one. Then what is the value for this one? Value for this one is if we simplify this one, then this becomes n minus 1, n minus 2, up to n minus x minus 1, n minus x minus 1 into factorial n minus x. We write the factorial n in such a way. Now, in the denominator, this becomes factorial x into factorial n minus x into lambda by n to power x into 1 minus lambda by n into power n, and here we write 1 minus lambda by n to power minus x. So we separate this one, nothing else. This one is a simplified form. So in case of a Poisson distribution, what will happen? Limit n tends to infinite. Here we take, so limit n tends to infinite, taking limit n tends to infinite. N tends to infinite on both sides. Then left hand side, limit n tends to infinite, b x np equal limit n tends to infinite, So if we simplify this one, then what will happen? This will become what? This will become from here n to power x. So here n outside, so this one, and here we write n minus 1 and outside, then this becomes n into 1 minus 1 upon n. First term. Second term becomes, then again n square and outside, then what will happen here? This becomes n outside from here, then this becomes n square from third term, then this becomes similarly how many number of a term? 1 term, 2 term up to x minus 1, so this becomes n to power x minus 1, n from this term, outside from this term up to n minus x minus 1. So n, then n square, n to power 3, n to power 4, similarly n to power x minus 1 into 1 minus 1 upon n, 1 minus 2 upon n. Similarly, last one is a 1 minus x minus 1 upon n. And from here, what will happen? If we write lambda to power x divided by what? N to power x. Just we simplify numerator and denominator, lambda to power x and n to power x. This becomes 1 minus lambda by n to power n into 1 minus lambda by n to power minus x. Divided by what? Divided by factorial x and this one cancel out, this one and this one cancel out. So here we write a factorial x. So if you closely observe this one n into n to power x minus 1, so this one cancel out with the power of a n to power x, because n into n to power x minus 1 become n to power x, and this one n to power x, this one cancel out. So this one become what? if we take a limit, so here if we closely observe this one is a lambda to power x divided by what? Factorial x. And this term become what? This term become 1, this term become 1 upon n 0, 2 upon n 0 because n tends to infinite. So this term become what? 1. So what is the value? Value become lambda to power x, and limit n tends to infinite 1 minus lambda to power n, this become what? This become e to power minus lambda. This become e to power minus lambda. The value for this one, limit n tends to infinite 1 minus lambda by n to power n. And what is the value for this one? This one 1 minus lambda by n, this become 0, lambda by n become 0, so 1 to power this one, so this one become 1 divided by what? Factorial x. So this one is a what? This one is denoted by the Vx lambda. This one is a what? Sorry, not a Vx lambda, this one is a Poisson distribution, so here we denote this one is by the P. So P x lambda. This one is a what? This one is a Poisson distribution. This one is a Poisson distribution. Px lambda, there are two parameters, lambda and x. Lambda equal np, and this one equal lambda to power x into e to power minus lambda divided by factorial x. So this one is a what? This one is a Poisson distribution, limiting case of a binomial distribution. If we formally define the Poisson distribution mathematically in terms of a probability mass function, then how we define x is a what? X is a random variable. A random variable, a random variable, a random variable, random variable x is said to be, x is said to be follow Poisson distribution, a random variable x is said to be a follow Poisson distribution if for non-negative values, for non-negative values, the probability mass function, the PMF probability mass function is defined as, if the probability mass function is defined as what? Probability of x equal e to power minus lambda to power x upon factorial x. Now what is the values of x? Now values of x become what? X equals 0, 1, 2, 3 up to infinite. And for all other, what is the probability? For otherwise the value is a 6. Otherwise value is 6. Otherwise value is a 6. So this one is a what? This one is a mathematical definition of a Poisson distribution. There is a random variable. Obviously that random variable, the outcome of a random experiment, in this case is a what? Discrete random variable. So this random variable is a discrete random variable. If this one follow this probability mass function, then we say that the distribution is a what? The distribution is a Poisson distribution. Now, how we say this one is a probability mass function? And we know that sum of the probability become what? Sum of the probability become 1. Yes, then we say that this one is a probability mass function of any distribution. So how we verify this one? First we verify this one. Probability mass function means probability, here we find sum of a probability. So what is the, in this case this becomes summation x equals 0 to infinite, because here we consider the non-negative values. So non-negative value means a positive value with 0. Probability of x equal x. Now, what is the probability mass function? Probability mass function is here. This may be written as what? This may be written as summation x equals 0 to infinite. Now, what is the value of a probability of x equal x? What is the probability mass function? E to power minus lambda lambda to power x upon factorial x. So e to power minus lambda is free from the summation, so this may be taken outside from this one. So this becomes e to power minus lambda summation x equal 0 to infinite lambda to power x upon factorial x, and you know that this one is a what? This one is an expansion of e to power lambda. Or you may write this one in this way. This becomes e to power minus lambda inside 1 plus lambda square upon factorial to up to infinite number of a term. So this may be written as e to power minus lambda, and what is the value for this one? The value for this one is e to power lambda, and what is the value for this one? This one is 1. So you may say that this one is a what? This one is a probability mass function. So here sum of the probability is about 1. Now we discuss some properties of a Poisson distribution and try to find out some statistics of a Poisson distribution. Then we discuss some numerical example based on. So what we are going to find out? We are going to find out what? We are going to find out moments about any point. Then with the help of a moment about any point, we find a moment about mean. Means first we find mu1 dash, mu2 dash, mu3 dash, mu4 dash. Similarly, we able to find out mu_r dash, but only we derive the mu1 dash, mu2 dash, mu3 dash and mu4 dash. Then with the help of a mu1 dash, mu2 dash, mu3 dash, mu4 dash, we find mu1, mu2, mu3 and mu4. Once we find the mu1, mu2, mu3, mu4, we find the beta1, beta2 and gamma1, gamma2. Then we find a moment generating function, the recurrence iteration of a moment. Then we solve some numerical problems. So moments in case of Poisson distribution. So here if we talk about the moments of Poisson distribution. So as we know that what is the moments in terms of expectation, the value of a mu1 dash means a moment about origin. This one is the expected value of x. Expected value of x in case of a random variable. X is a what? X is a random variable. If we write here, this one is a what? This one capital X, because random variable is denoted by the capital X, capital Y, like this one. So mu1 dash equal expected value of x, and in case of a discrete random variable, what is the expected value of x? This one equals summation x equal minus infinite to infinite x into probability of x equal x. So in case of a Poisson distribution, what is the value for this one? You may divide this summation into two parts. First part is what? So first part is x equal minus infinite to minus 1, x into probability of x equal x plus summation x equal 0 to infinite x into probability of x equal x. Then obviously for because Poisson distribution is defined for the non-negative values, so what is the probability for from minus infinite to minus 1? Probability becomes 0. So what is the value for first term? First term becomes 0. 0 plus summation x equals 0 to infinite x into probability of x equal x from x equals 0 to infinite. What is the probability mass function? This one is a lambda to power x into e to power minus lambda divided by factorial x. So after simplification, what is the value? Value become summation x equals 0 to infinite. Here we write x into lambda to power x into e to power minus lambda divided by what? Factorial x can be written as x into factorial x minus 1. Then this x cancel out. So here we try to write in term of a what? In term of a lambda to power x minus 1 e to power minus lambda upon factorial x minus 1. Because some of the term from 0 to infinite become again e to power minus lambda, and the value of e to power lambda and e to power minus lambda become 1. So here we try to write what? We try to write this one. If we write this one here, lambda into lambda to power x minus 1 into e to power minus lambda divided by factorial x minus 1. So here lambda with the free from the summation, because this one is a summation from x. Now x equals 0 is not defined, so here we write from x equal 1 to infinite. So this become what? If we write here mu1 dash equal lambda outside, this becomes summation x equal 1 to infinite lambda to power x minus 1 into e to power minus lambda divided by factorial x minus 1. Again this one is a what? X equal 1 to infinite e to power minus lambda, lambda to power x, this one equal what? This one equal 1. For sake of simplicity, here we write lambda into e to power minus lambda outside, and here this become what? 1 plus x equal 1, then this become 1. 1 plus lambda square up to infinite number of terms. So what is the value for this one? Lambda square upon factorial. Sorry, lambda square upon factorial. So what is the value for this one? The value for this one is e to power lambda. So this become lambda into e to power minus lambda into e to power lambda, and what is the value? Value become lambda. So what is the value for mu1 dash? Mu1 dash equal lambda. Similarly, we are able to find out the mu2 dash. What is the value for mu2 dash? Mu2 dash means moments about the origin, second moment about the origin. This one is a what? This can be written as a mu2 dash is expected value for x square. Expected value of x square and expected value of x square equal what? Summation x equal minus infinite to infinite x square probability of x equal x. This one is a. Now x square can be written as what? X square can be written as, in form of factorial notation, this can be written as summation x minus 1 plus what? Plus x. So this becomes x equal minus infinite to infinite. This becomes probability of x equal x plus summation x equal minus infinite to infinite x into probability of x equal x. Why we write in this form? X square can be written as x minus 1 plus x. So x square minus x plus x become what? X square. So here already we find out the value for this one, x equal minus infinite to infinite, x equal minus infinite to infinite, x probability of x equal x. The value for this one is a what? The value for this one is a lambda. So here there is no need to calculate this one. And if we closely observe this one, x into x minus 1 probability of x equal x. So here if we write this one again minus infinite to minus 1, the value becomes 0. So here summation x equals 0 to infinite, this can be written as x minus 1. And what is the probability of x equal x? This one is a lambda to power x e to power minus lambda divided by factorial x. Again we write a factorial x equal what? X into x minus 1 into factorial x minus 2. Then x and x minus 1 cancel out. Then what is the value? After simplification like this one, this becomes what? Lambda square. So plus lambda. This one is the value for what? Mu2 dash. So in a similar manner we find the value for mu3 dash, mu4 dash. I am not going to derive the value for mu3 dash and mu4 dash directly. Here I am going to write the value for mu3 dash and mu4 dash. So once we erase out here, then we write down the value of these. So as we derive the value for mu1 dash is what? The value for mu1 dash equal what? The value of mu1 dash is a lambda. The value of mu2 dash is a what? Lambda square plus lambda. Similarly, what is the value of mu3 dash? Mu3 dash equal lambda square, lambda cube plus 3 lambda square plus lambda. And mu4 dash equal what? Lambda to the power 4 plus 7 lambda square, 7 lambda cube plus 6 lambda square plus lambda. Once we verify the value of this one, either this one is a correct or not. So this one is a correct one. So this one is the value of mu4 dash. Mu4 dash equal lambda to the power 4 plus 7 lambda to the power 3 plus 6 lambda square plus lambda. And we know that what is the relation between how we find the value of mu. What is the value of mu1? Mu1, obviously the mu1 equal 0. So there is no need to find out the value of mu1. Mu2 equal what? Mu2 dash minus mu1 dash whole square. So what is the value for this one? So what is the value for mu2 dash? Mu2 dash equal what? Mu2 dash equal lambda square plus lambda and minus mu1 dash whole square minus lambda square. So this one cancel out. What is the value for this one? The value for mu2 equal what? The value for mu2 equal lambda. Now similarly we find the value for mu3. Mu3 equal what? Mu3 equal mu3 dash minus 3 mu2 dash mu1 dash plus mu1 dash whole cube. Once we verify the value for this one, either this one is correct or not. So 2 mu1 dash whole cube. This one is 2 times after this one. So you may write this one with the help of a relation between mu1, mu dash and mu. So here, if you put the value for this one, mu3 dash equal what? Mu3 dash equal lambda cube plus 3 lambda square, lambda cube plus 3 lambda square plus lambda minus 3 mu2 dash. Mu2 dash is a lambda square plus lambda. Mu1 dash, this one is a lambda plus 2 mu1 dash cube lambda cube. So if you simplify this one, what is the value for this one? Lambda cube plus 3 lambda square plus lambda. If you simplify this one, minus 3 lambda cube minus 3 lambda, here you will write the 3 lambda square plus 2 lambda cube. So if you closely observe this one, so what is the value for this one? Minus 3 lambda cube, this one is this 3 lambda cube, and this one cancel out. What is the value for this one? And this become what? 3 lambda square, and this one cancel out. 3 lambda square and 3 lambda square. What is the value for mu3? Mu3 become lambda. Now in a similar manner, we find the value for mu4 also. And I am not going to derive the value for mu4 here. We write directly the value for mu4 is a what? The value for mu4 is a 3 lambda square plus lambda. 3 lambda square plus lambda. So this one is the value for mu1 dash, mu2 dash, mu3 dash, mu4 dash, means moments about Poisson, moment about any points. This one is a mu2, mu3, mu4. These are the values of moments about a mean. Now if we talk about other statistics, means based on a moment. So what is the value for beta 1? Beta 1 equal what? Beta 1 equal mu3 square upon mu2 cube. And what is the value for this one? Mu3 square means a lambda cube, lambda square divided by mu2 cube. What is the value for mu2? Mu2 is a lambda, so this becomes lambda cube. What is the value for this one? 1 upon lambda. And what is the value for beta 2? Beta 2 equal mu4 upon mu2 square. So what is the value for mu4? Mu4 here, mu4 is a 3 lambda square plus lambda divided by mu2 square. Mu2 square equal what? Lambda square. So this become what? 3 plus, if we simplify this one, lambda and lambda square cancel out, 3 plus 1 upon lambda. So as we know that this one give the what? This one give the lack of a symmetry. means a coefficient of a skewness. So if the value for beta 1, equal to 0, then symmetric. In other words, what we say? We say that the value for 1 minus 1 upon lambda equal what? 1 upon lambda equal to 6. So you cannot say the value for 1 upon lambda equal to what? 0. So 1 upon lambda equal to 0. So always what we predict, Poisson distribution is a skewed curve. This one is a non-symmetric curve. You cannot say 1 upon lambda equal to 0. So only for the value of lambda equal to infinite, the 1 upon lambda equal to 0. So lambda cannot be infinite. So always what we predict? Always the Poisson distribution is a skewed curve. Skewed curve means either this one is a positively skewed or negatively skewed. This one depends on the value of lambda. Second one, beta 2 equal 3 plus 1 by lambda. Beta 2 equal what? Beta 2 equal, if we write here, not here, if we write here, beta 2 equal what? Beta 2 equal 3 plus 1 by lambda. And we know that if beta 2 equal minus 3, beta 2 equal to 3, so and beta 2 equal 3 plus 1 by lambda, beta 2 equal to 3, then basically this one is a what? This one is a normal curve. Otherwise, if the value for beta 2 equal what? So beta 2 equal to 3. What is the meaning of this one? If beta 2 equal to 3, then this one is a normal curve. Here, if you put beta 2 equal to 3, then what is the value for 1 upon lambda? 1 upon lambda equal what? 1 upon lambda equal 0. So again, 1 upon lambda cannot be equal to 0. Then what we predict? We may predict what? We may predict the Poisson distribution. What we conclude here? Poisson distribution is not a mesopotic. Poisson distribution cannot be mesopotic. I be write clearly here. Poisson distribution cannot be mesopotic or normal curve. What is the meaning of this one? Means a Poisson distribution is either highly peaked or low peaked. Means either leptokurtic curve or platykurtic curve. So leptokurtic distribution or platykurtic distribution. So if the value of a beta 2 is greater than 3, then this one is a what? Leptokurtic. Means the value for 1 upon lambda is greater than 3, greater than 0. Then this one is a what? This one is a leptokurtic. Means if beta 2 is greater than 0, if beta 2 is less than 0. So if beta 2 is greater than 0, then what will happen? Leptokurtic. And beta 2 is less than 0, then platykurtic. So in this way, be able to analyze the statistics of a Poisson distribution, as well as in a similar manner be able to find out what? Be able to find out other statistics like mean deviation of a Poisson distribution, and also some other statistics of a Poisson distribution. Now we are going to find out a moment generating function and recurrence relation of a moment generating function. Then we solve some numerical example. So Now next one is a what? Next one is a